In this class, let us learn conversion of galvanometer to voltmeter. Galvanometer is a device used to detect the presence of current. But it is a highly sensitive instrument. It shows full-scale deflection even for a small current. So it cannot be used to measure current or voltage, but it can be converted to voltmeter or ammeter. A voltmeter is always connected in parallel with a circuit to measure the potential difference across it. And the voltmeter should draw a very small current, so its resistance should be very high. So voltmeter is a high resistance instrument. In order to convert a galvanometer to voltmeter, a high resistance is connected in series with it. G represents the galvanometer with a resistance Rg. The high resistance R is connected in series with the galvanometer. The galvanometer and the resistance together form the voltmeter. And this voltmeter is in connected parallel with a circuit. It measures the voltage. The measured voltage V is equal to Ig, current through the voltmeter. It is the current for full-scale deflection of the galvanometer. Ig into Rg plus R. Therefore, V by Ig is equal to Rg plus R. So, the resistance R to be connected, R is equal to V by Ig minus Rg. The resistance of the voltmeter is given by R plus Rg. An ideal voltmeter has infinite resistance. And as the range of the voltmeter increases, the resistance to be connected also increases. So the resistance of the voltmeter increases with the range of the voltmeter. Therefore, voltmeter has higher resistance than a millivoltmeter. Now let us see the conversion of galvanometer to ammeter. Ammeter is a device used to measure the current through a circuit. It is connected in series in a circuit as it measures the whole current through it. So the resistance of the ammeter should be very low, as it should not change the current in the circuit. So ammeter is a low resistance instrument. So in order to convert a galvanometer to an ammeter, a low resistance called shunt resistance S is connected in parallel with it. G is the galvanometer and S is connected in parallel with the galvanometer. So when the circuit current is I, a small part of the current Ig flows through the galvanometer and the rest of the current I minus Ig flows through the low resistance S. This resistance is called shunt resistance. Ig is the current for full-scale deflection. Since both are connected in parallel, the PD across galvanometer is equal to PD across shunt. So Ig into Rg is equal to I minus Ig into S. Therefore, S is equal to Ig Rg by I minus Ig. Since the resistors are in parallel, the effective resistance is given by 1 by Ri is equal to 1 by Rg plus 1 by S. Ri is the resistance of the ammeter, which is given by Rg into S by Rg plus S. the resistance of the ammeter will be less than the low resistance. Yes. An ideal ammeter has zero resistance. As the range of the ammeter increases, the I value increases, then the shunt resistance decreases. So we can say an ammeter has a low resistance than milliammeter. Thank you.